Vector calculus practice. Divergence of a vector field. Practice problem set. This is a calculus topic. The practice set is best done by trying the problem, then moving on to the solution. So you may want to pause. Once you see the solution, it sort of ruins the problem. You must do them cold, or you won't understand where your weaknesses are. Of course, you could also use this as 10 examples. The divergence from a dot product of the del operator and the vector has a scalar as an output. Now, technically, the del operator is not a vector, but I'm going to put it in vector notation because it operates like a vector. It's the partial with respect to x times the unit vector in the x direction, which is implied by putting the partial in the first position. The partial with respect to y times the unit vector in the y direction. The partial with respect to z, the unit vector in the z direction. And just find bracket notation a lot more convenient. Find the divergence of 2x, 3xy, 4z. Well, the divergence is a dot product, which means we take the x coordinate here, or the x coordinate here, and the y's, and the z's, and we add the pieces. So the partial with respect to x of 2x is 2, plus the partial with respect to y of 3xy. You treat the x as a constant here. So it's 3x, the derivative of y is simply 1. And the partial with respect to z of 4z is 4. So that is 6 plus 3x. Find the divergence of x squared plus 2y, 3yz, 4x squared z. The partial with respect to x is 2x plus the partial with respect to y is 3z plus the partial with respect to z is 4x squared. Now here, when we took the partial with respect to x, the 2z is treated as a constant, and the derivative of a constant is 0. You may be surprised so many students will actually try to do something with the 2y other than write down the 0. And it is there to see if you will recognize it and know what the derivative of a constant is. Find the divergence of x squared plus 2y e to the xy x e to the x. Okay, so again, we look at partial respect to x. The x squared plus 2y, here's a 0. So it's 2x, what that we can do. The partial of e to the xy, partial of e to the x is e to the x. So e to the ax is a e to the ax. We treat the x, or I should say, e to the partial respect to y of a e to the ay is a e to the ay, the a being x in this case. So we got x e to the xy. Here, there is no z dependency. So we take the partial respect to z and we get 0. So it's 2x plus x e to the xy. Find the divergence of sine x, sine x, sine x. This one's rather simple, but there is a pitfall. When I take the partial respect to x of sine x, I get cosine x. When I take the partial of sine x with respect to y, I get 0. The partial with respect to z of sine x, I also get 0. So my answer is cosine x. A lot of students are going to somehow see a y here and a z here. You have to use the problem that you're given, not transform it into the one you think it should be. Find the divergence of sine 2x, sine 2y, sine 2z. Now here the variables are, as expected, x, y, and z. So the derivative of sine 2x is 2 cosine 2x. The sine 2y is 2 cosine 2y. And the sine of 2z is 2 cosine 2z. Find the derivative, the divergence of x squared, xy, z. The partial with respect to x of x squared is 2x. Partial with respect to y of xy is x. The constant, or treated as a constant in front of the y. And the partial with respect to z of z is 1. And so we get 3x plus 1. If you don't consolidate, if I were grading it, I would ignore it. I really don't think that's the focus of the problem. The focus is, do you know what to do with the divergence, and do you know how to take the partial derivatives? But depending upon your teachers, some people are very strict about putting things in nice consolidated form. You have to answer tests according to what book pass. Find the divergence of 3x, 4y, z. Partial with respect to x of 3x is 3. Partial with respect to y of 4y is 4. Partial with respect to z of z is 1. So we have simply single-digit numbers to add. 3 plus 4 plus 1. The divergence is 8. Find the divergence of the hyperbolic sine of x, y, the hyperbolic cosine of x, and z, the hyperbolic cosine of x. Partial with respect to x of the hyperbolic sine of x is the hyperbolic cosine of x. The partial with respect to y of y, the hyperbolic cosine of x, we treat the hyperbolic cosine of x as a constant here. So the derivative of y is 1. So we get the hyperbolic cosine of x. And likewise with the z, the hyperbolic cosine of x is hyperbolic cosine of x. And the partial of respect to z of z is 1. So we get 3 times the hyperbolic cosine of x. Find the divergence of y, z, to y. Some vector fields just have no convergence. The partial with respect to x of y is 0. Partial with respect to y of z is 0. And the partial with respect to z of 2y is 0. The divergence here is 0. Find the divergence of xy, xyz, bob z. The partial with respect to x of xy is y. Partial of xyz with respect to y is xz, and the partial with respect to z of phi z is phi. Well, I thank you for watching, and I have others. This one was the practice set. There's one on the theory of the divergence. I have the divergence and curl together. I also have one with the gradient, the theory, one on practice with the gradient. So there's a lot of different things, and I have more than calculus. So I would appreciate if you would subscribe to the channel. More are coming, and you can keep up with your studies. If you have a special need of a certain topic, please feel free to uh, just go ahead and drop a comment, and I'll see if we can put it in. It depends on Tom, of course, but I'll see if I can do something.